This tutorial is going to demonstrate how to do a Goodman and Kruskal gamma test on R. Goodman and Kruskal gamma is a non-parametric measure of the strength and direction of an association that exists between two variables which are measured on an ordinal scale. Ordinal data is when you have categorical variables that have built-in gaps, but the difference between the gaps is not all the same. So for example, if you're using a Likert scale ranging from strongly disagree to strongly agree, there is an order to this scale, but the difference between the levels is not the same. Ordinal data differs from categorical data, which has no order. For example, eye colour, like red, blue, green, etc. While it's possible to analyse ordinal data using other tests, like the Spearman's rank order correlation, Goodman and Kruskal's gamma is recommended when your data has many tied ranks. And this means when you rank your data, multiple observations have the same value. In this tutorial, we are going to use a Goodman and Kruskal gamma to understand whether there is an association between restaurant rating and price, where there are 5 possible star ratings for a restaurant, and the price bracket can be split into 3 categories: cheap, average, and expensive. So for this tutorial, we're going to create a simulated dataset of 200 observations using the following code, where n is the number of simulations we want to create, or number of observations, so this would be 200. Ordinal underscore data is what we're going to call this dataset. And then we have our variables. So we have price, which has 3 levels, and rating, which has 5 levels. Before we run our test, we need to make sure our variables price and rating are being read in R as numeric. Sometimes R likes to read in ordinal data as a character, and this would cause an error when you try to run the test. So to do this, we can use the function as.numeric. The next thing we need to do for the specific function we're going to use to run the Goodman and Kruskal gamma is to convert our data frame to either a matrix or a table. And you can do this by either using the as.table function or as.matrix function around your dataset name. Now we're ready to run our Goodman and Kruskal gamma test. We can run it using the Goodman-Kruskal gamma function from the DescTools package. So first you will need to install and load this package, and then you can use the Goodman-Kruskal gamma function. In this function you need to specify your dataset, which we called ordinal data, but this is whatever you read your data in as or call your data frame, and then you need to specify the confidence levels. Typically we use 95% confidence levels, but you can change this here. And this is the output we get. As you can see here, we have the gamma statistic and the lower and the upper confidence levels. So the gamma statistics ranges between -1 to 1, where -1 is a strong negative association and 1 is a strong positive association. So the interpretation is a bit like when you do a correlation. As you can see here, our statistic is 0.05, so it's quite close to 0, which means there's no association at all. But do remember this is a simulated data set, so it's essentially made up. You can get an idea of whether this would be significant or not by looking at the confidence intervals. So if the confidence intervals cross 0, it's unlikely to be significant, but this piece of code does not give you a p-value. Just a little note as well, if you've used my code to create a dataset, your output might look slightly different, and this is because we are making a new dataset every time we run the simulated code. So, like I said, that piece of code doesn't give you a p-value, but what about if we want them? Well, there are actually many ways we can run the Goodman-Kruskal gamma on R. There's a lot of different functions in a lot of different packages. So an alternative way is to use the GK gamma function from the MESS package. So to do this, you can go through the steps of the tutorial and follow the steps in exactly the same way. Although for this function, you do not need to convert your data to a table or matrix for it to work. And then the only difference is that you use the GK gamma function instead, where you do not need to specify the confidence intervals. Then you can run it in the same way, and as you will see here in our output, we have the gamma statistic and we also have the p-value. So our gamma statistic is different to the one on the slide before because we've created a new data set, and we can see that our p-value is not significant. So here are the two methods that are used to do this test on R. There are obviously many more ways to do this, but this was just to give you a quick tutorial of how you can. Thanks for watching.